A ball of mass m collides with a wall and bounces back in a straight line. It collides here and it bounces back in the same straight line. The ball loses 75% of the energy, of the initial energy, which means what? It has already lost 75%. What is the energy which it bounces back? Okay, it bounces back only with, let us say, E is the initial energy. It bounces back only with the energy of E by 4, right? 3E by 4 it is already lost. The speed before the collision is V. What is the magnitude of the impulse on the wall by the wall? Okay, so what is the impulse? Impulse is nothing but F times delta T is nothing but your impulse, or this can also be called as delta P, right? Now let us see what is delta P over here. M into V is the initial momentum. M into V is the initial momentum. Is asking about the magnitude. Okay, so according to us, delta P is nothing but P final minus P initial. What is P final? M times V final minus M times V initial. We do not know what is M times V final over here. Let us determine from here. So we know it's E by 4 is the outcoming energy over here. So what is E by 4? E by 4 should now be equal to half mv final square, which should now be equal to half mv. Okay, let me write. So this should now be equal to 1/4 of what is the initial energy? Half mv square, right? So therefore, if I equate these two, see this and this if I equate it, half mv final square is equal to so much. Then what happens? This m and this m goes away, this half and this half goes away. So V final should be equal to V by 2, right? So therefore, your final momentum should be equal to m times V final, which should be equal to mv divided by 2 minus m into V. Now let us see. So if I consider this as positive, this should be negative, which means this should be negative, this should be negative. So what do I get here? I can now write this as equal to minus 3 mv divided by 2. So your delta P is equal to minus 3 mv by 2. If I take just the magnitude, this should become plus 3 mv by 2, which is the right option. D is the right option. Okay, let us move on to the next one.